Welcome back. So here we are at the very end of our stage asset. There's really only one parameter left that I would like for us to add. It's not a necessity. We don't have to have this parameter, but it allows us to introduce you to a new parameter type that we can add on to our asset. It also allows us to introduce you to a new expression function as well. So this is some pretty cool stuff. Basically, what we're going to do is add a custom parameter that will allow an artist to specify a floor for our stage. That way, the artist can simply go in there and say, all right, we've got our floor geometry, we've got our stage. Let's go ahead and make sure that our stage sits on the floor no matter where the floor is moved to.
Oh, and this is great because we can reuse this later and we can say, okay, I want the pool to sit on the stage, I want the ladder to sit on the stage, and we just specify a floor object. And that object will be the base that our object sits on top.
Now, as a reminder, this isn't something that you have to do. Again, this is just allowing us to introduce some new concepts. You could just simply translate the object to the position where you want it to be at. So with that, what I want to do is jump over here to the whiteboard. Plus another cool thing, just showing how to have one object interact with another object through the B-box expression is pretty cool as well. So, and for those of you that went, what? Don't worry, we'll see that in just a second. So we've seen that we've got integer parameter types, we've seen that we've got floats, colors, vectors, etc. The new type that we're going to be introducing you to in this video is our operator path type. So let's go ahead and jot that down. And this is really handy when you have an asset that needs to make some sort of reference to another node. So with this, you're automatically going to get the little browser button. So you click on the browser button, and it's going to allow you to navigate through a tree and find a node. Now, we have the ability to set up a filter. Now, we've seen that we can establish things like ranges when working with integer and float values. You know, give me a number that's no less than this or no greater than that. Well, here with operator path, we have the ability to go in there and say an artist is only allowed to select X, the following type of nodes. And in our particular case, we're going to want to make sure that only objects, and more specifically, only geometry objects can be selected by an artist that is putting something into the operator path parameter. And it only makes sense. You wouldn't want an artist to specify a camera. Exactly. And you want to make sure that your stage is always sitting on top of a camera. That would be kind of odd. It needs to always sit on geometry in our particular case. So we're going to be able to take this guy and set up a filter to where only object, and then we can basically select object geometry only, and that's what we're going to do. I'm just going to write geo only. I think everybody will get the idea. Now, again, we've now filtered out everything that can be selected from the tree to just geometry at the object level. Okay, so now what do we want to accomplish? Well, we know that we've got our stage, and we know that we've got a floor, and that floor may have been moved up or down in translate Y. We want, when an artist sets the operator path to point to our floor, in this particular case, this guy right here, we want for our asset, our stage asset, to automatically position itself in the y-axis such that it is now sitting on top of this. Now, there is a simple way to go about this expression. There is a more complicated way. There is a much more complicated way. And then there is the mind-bending, ultra-complicated way. We are only going to account for bounding boxes, and I'll talk more about bounding boxes in just a second, and translation in the y-axis of objects. That's it. We're not going to worry about scaled objects. We're not going to worry about where pivot points are located. We're not going to worry about rotated objects.
Rotations would become interesting.
The bottom line is this. The math becomes more and more complex.
Exactly.
And come on now. This is a TD course. Math is good. But we start to kind of brink on the edge of becoming silly when we're worried about super long expressions where we could just have an artist use a translation handle to position it on top of the object that needs to act as the floor.
And at that point, we're really digressing from the purpose of this project.
Exactly. And I just don't see where something like that would be critical in the real world because you're just saying, position this on top of this guy. Use the move handle and put it there.
As the development time in putting together a complete expression that's completely robust, you could probably position 1,000, 2,000 objects in that time.
Exactly. So, again, we're just introducing some new concepts here, and we're going to keep this to a very simple expression. For those of you that are interested in seeing some more interesting maths in this project, don't worry. There's plenty of that yet to come. All right, so bounding boxes. What is a bounding box? If I was to create a sphere, a bounding box would be a box that would fit around the sphere in such a way, actually I've drawn it just a tad bit too far, that would be more like this and come down, that all of the corners, or all of the most extreme edges, or I don't even want to say edge, the most extreme part of the surface of your geometry would touch the top, the bottom, and all of the sides of this box that was around your geometry.
And we briefly touched on this when we were talking about positioning our spheres for support for the stage, and how we wanted to line up the very edge flush with the edge of the stage. It's exactly the same here. We have a box that lines up flush to the extremities in Y, X, and Z.
Exactly. So we're interested in the bounding boxes of our floor geometry as well as our stage geometry. So this guy right here, now I'm going to draw this slightly off, but just pretend it's touching the most extreme upper, lower, and outer all the way around surfaces of our stage. That is our bounding box. Now with our bounding box, we basically have some variables that we can access when we are looking at ourselves as the geometry. We can say, what is the maximum in Y? Now, here's the way this works. Let me see the best way that I want to. Let's just explain this with some circles. We'll keep things very simple so I don't have to draw out a bunch of complicated stuff. This circle shall represent our stage. And down here, what I'd like to do is draw the origin of the world. Okay? This guy, I'll do another, I'm thinking, bear with me everyone, because I'm just kind of making this up on the fly. We'll do a box. And this box is going to represent our floor. So the goal here, and this is going to be origin once again, so just pretend those two lines are aligned with one another. Our goal is to get this guy sitting on top of the box, because the box is going to act as the floor. So how would we go about doing that? Well, the bounding box that's around here gives us access to values that are absolute values in the real world. So they're relative from the origin of the world, if you will. We have access to, we have Y max, because right now I'm only interested in this particular demonstration, the y-axis, because we're dealing with up and down.
And that is a
dollar. I already know where you're going with that. And this is dollar y min.
And the reason they're dollars is we're dealing with ourselves, we're dealing with the local variable form of the bounding box information.
So this y min is from the origin, and this y max is as well. Okay? What I want to do to make this as simple as possible is figure out how I would need to calculate my numbers such that I could basically simulate this sphere sitting on the origin, sitting on the ground as demonstrated here. Now, we also, over here, we have a y max and a y min. So let me go ahead and just draw out y max. And we know that, I'll draw on this side, this is our y min. Of course, we know that runs all the way through. But again, I'm just trying to keep our drawings nice and clean. I'm not going to use a dollar sign on this side because we are referring to the stage asset. So we are referring to ourself. On ourself, we will be creating a custom parameter of type operator path. So when we start using expressions on ourself, we have access to our local y min, y max, etc. But when we are dealing with an expression on ourself and we want to talk to another object and find out the y min, y max on that object, we have to use an expression function in order to get that information. So we will not be using $y min or $y max. So let me go ahead and undo that. And we'll talk more about that in just a second. So in order to get this sphere, which is at the moment standing in for our stage, on the ground, all I would need to do is subtract away $y min. Okay? So let's say that that's 5 units between there and here. If we subtract that 5 units away, you'll see that our stage would be sitting down on the construction plane. Okay? So we could say just minus $y min. Fantastic. Now I need for my stage to be sitting on top of the geometry that I specify will service the floor. Well, where is our floor level at? Our floor level is at y max, because y max, again, absolute, all the way from the origin up, so all the way up to there. So if I went with something like y max minus $y min, wouldn't that give me exactly what I want? Haven't I, by doing minus $y min, haven't I more or less zeroed this guy out, because he's now sitting on top of our origin? And then I say, all right, go from the origin up to y max. Wouldn't that make it look like to the stage that this right here is the construction plane, or the origin? So if we move up that amount, we'll be sitting right there on top. That's fantastic. Now, we need to take into account that the artist may have also translated the floor as well. Because please keep this in mind, this is so important. When dealing with geometry, are you dealing with geometry from an object point of view? Meaning, are you just dealing with the geometry container which has transformation parameters? Or are you dealing with it from inside that container at the SOP level? And that's where things get very interesting. So right now, everything we've been talking about, we're dealing with the SOP level. But up at the object level, an artist may have created his floor and then moved his floor up and over, and that's where he wants to have the floor sit and then put the stage on top of it. So we need to take into account, at the object level, it's translate Y.
Exactly, because the object level transformations don't affect the bounding box information that we get through Y max and Y min.
Exactly. Now, this is the very simple expression that we need to use. But of course, that's not how it's going to look when we jump into Houdini and we have to lay it out. What's it going to actually look like? How do we get the Y max information? Well, let's take a look at that. First thing we're going to need to do is talk to the object that the artist specifies in the custom parameter that's of operator path type. Now, this custom parameter is going to be I believe you're going to call it floor OBJ.
Yeah.
So you're going to have on your digital asset, you're going to have this nice little guy with a little ability to go in here and select a little picture over here. And this is going to be our floor OBJ. And let's say that you click the button and everything's been filtered out so that you're only looking at basically just geometry nodes at the object level, and you see floor and you select floor. So let's say floor is what has been entered into there. And this is pretty much what you guys are going to see in a few minutes when we get over into Houdini. Now, the expression that we're going to use for controlling, I assume, Steve, at the end, since I haven't seen how you're going to do this, you're just going to wire this final merge out into a transform
Yeah,
node?
I'm just going to wire into a transform SOP right at the bottom of our network, put this expression in translate Y on that SOP, and make sure that's where our visibility is.
Beautiful.
It's as simple as that.
Yeah, okay, that only makes sense. I wanted to ask just to make sure.
Sure.
So, again, Steve's got this beautiful network, and I'm going to represent the entire network with just a box, and coming out of it at the very end, he's just going to wire it into a transform node. Now, this is down inside our digital asset. And this transform node, so let me just put an X right here. On translate Y, this is where the expression is going to go. So, once again, this is why we have access to $y min, because here we are dealing with ourselves, our own geometry. But we need to reference this y max. So how are we going to go about doing that? Well, we have an expression function that we can use called bbox for bounding box. So bbox, no different than you guys seeing ch, where we've used ch in the past. Now, bbox is going to take in a node, and then it's going to take in for what piece of information from the bounding box are you looking for. So for the node, well, all we have is this custom parameter, and from the custom parameter, we need access to what they've entered into that box. Now, in order to do that, we need to use something like ch. The ch expression function returned a value back to us. Remember, we were able to say, give me size z, and then ch would just simply return us a number. But in this particular case, we're not dealing with a number. We're dealing with alphanumeric text. So we're dealing with a string. So instead of ch, we'll use chs for a channel string. So inside here, we're going to have yet another method, another function. So we're going to have chs. And with chs, now inside this function, we can refer to our floor object. So we can say, since we're down on that transform node, let's go ahead and step up to the asset level. And on the asset level, there's floor object. Let's close this guy off, and let's go ahead and close this off. This floor object is this guy, but CHS is going to evaluate that string for us. So it's going to give us that piece of information. Now, we're still inside of bbox. That's the first piece of information. So now what we need to do is give it the second piece, which is, what are we looking for? Are we looking for the y max, the y min, etc.? Okay. Now, the way that they've got it set up, basically the constants that are used are d underscore y min, y max. And again, that's just the way that it's been set up in Houdini. So since we're looking for y max, what we'll have to use is d underscore y max. And now we can go ahead and close off the function. This part of the function is going to give us the node, and it's the node that the artist specified. And this part of the function, the second argument, is going to tell us what piece of information that we'd like retrieved from the node that's been specified by the artist. And there's our y max. So that's fantastic. Now with that, we can simply turn around and say minus, there, this one's tough. You ready? $y min. Whew, that's hard. We're local, so let's use a local variable that's available to us right there. Now, outside of this, all we need to do is turn around and get ty. But where's ty at? Ty, and who is ty? For those of you that are new watching all this going, okay, this is kind of confusing. Well, ty that we're referring to is floor ty. So if we were to look at this spelled out, that would actually be /obj/floor. Now we're not going to climb down, we're just simply going to refer to translate y. That's it. This right here would give us the translate y information for the floor. So how do we get that? So we know we need to add, because we're going to add the translate y in. So if it's a small number, it's been taken away. If it's been added to, whatever it is, this is going to account for how an artist has moved the floor in the y-axis. So all we need to do is come in here. Now I'm going to write this on the next line because it's kind of long. We simply add ch, because we're looking for a numeric value now. So basically, let's take a look at the channel and get a value back. Well, what channel are we going to look at? Well, we're back in the situation where all we know is floor object is where an artist would have specified what node we're interested in. So we've got to look at floor object. Well, to get what has been entered into floor object, we need, once again, to use CHS, our channel string, and we're going to tell it ... So go up to the asset level and grab floor obj, piece of cake. But we have a little bit more that we need to do, because this right here only gives us part of the puzzle. It's going to give us this basically. Hang on, we need to, Steve just pointed out, thanks a lot, Steve.
You're welcome.
Let's put those quotes in there. It only gives us part of the puzzle. But remember, what we're looking to do is resolve the translate y into a number. We need to get that value. So this is where we're going to use concatenation, which is basically just appending to the end of a string more information. And here's what we're going to do. Plus, continue with our string, slash, ty. End off our quotes, so Steve keeps smiling, and we'll close this guy out right there. So picture all of this right there after this plus right there, so it's going to all go out that way. All right? So again, concatenation, what are we looking at? Well, this guy is going to basically return slash obj slash floor, and if we feed that into the ch expression, well, that's not going to be good. But we concatenate it to it, meaning append it to the end, /ty. And this right here is the same as that, meaning we're going to get the value, not this guy right here, but the translate y value, how far we've moved him up. Okay? So that's the information we need, and by setting this up, we're going to have our stage sitting on top of our floor. Steve, is there anything you want to add to this?
Other than just mentioning again that this doesn't take into account a lot of complicated parameters you could take into account, but this is a very nice, simple example of referencing other objects, and especially of using the operator path, which is a very cool parameter.
Exactly. So with that, let's go ahead and jump over into Houdini, and let's wire this guy up.
Cool, this is going to be nice and easy now, the explanation's out of the way. This is great. So we're going to jump down inside our stage, since we're going to work inside our asset. And I'm going to simply wire a transform SOP off the end of our network. So I'm going to right click on the output of our final merge and create a new transform. So enter to select him, enter to create. And let's rename this to sit on floor object underscore xform. Now we currently create our expression because we need that parameter to specify our floor object. So let's right click.
Let's go ahead and move our visibility down there as well, real quick.
All right. Cool. So let's right click on our stage in the path gadget. I'm going to come down to type properties, that is off the bottom of the capture region. So we can select from our huge range of parameters an operator path. And I will create that in the geometry folder. And let's give this a name of floor obj. And I'll give it a label of floor object.
Cool.
Now, by default, the op filter is set to any operator. We want to specify, we could specify any object, but we're actually going to specify object geometry only, as I explained a second ago. And with that, that's all we need to do to set up this guy. So I'm going to accept. I will right click and bring up the parameters for our asset so that we can see on the geometry tab. We've got our floor object. We can bring up the browser and we can select only geometry nodes. So let's grab our floor node and accept, just so that we have something in there. I do actually this time want to grab that as a absolute reference, just so it matches up with what we were talking about on the whiteboard. Fantastic. So we're going to be creating an expression in translate y. So I'm going to bring up the expression editor with Alt E. And our expression is going to be exactly the same as we saw on the whiteboard. We're going to use the bbox expression and grab our, up on our asset, we're going to grab our floor object parameter. We're going to evaluate that as a string. And we're going to grab the d underscore ymax piece of information when dealing with bbox. We're going to take that, we're going to subtract $ymin, that's our local ymin value, and we're going to add to that the translate y, which again will use the channel string expression to evaluate our floor object, and we'll concatenate /ty as on the end of that parameter to get the translate y parameter, which we're going to evaluate as a channel.
Now real quick, I want to point out the $ymin. Keep in mind what data is coming through the node right now. All of it. all of the stage geometry. So the bounding box that we're looking at for ymin, basically we're dealing with the entire geometry, the entire stage.
Because $ymin is local to the node that we're calling $ymin on.
Exactly.
It's local to this transform stop. The geometry on this transform stop is everybody.
That's right.
Fantastic. So with that, we can accept this expression, and we shouldn't see any changes just yet.
Our little bitty.
Oh wow, we already do see changes. If we recall, our stage was constructed such that our spheres were below the construction plane, and our box, basically our platform, was above the construction plane. It's shifted up such that it now sits on the floor. Let's boost this guy up slightly. That'll probably make much better.
So now let's go ahead and translate our floor up.
Fantastic. So I'm going to grab the move tool.
Excellent.
Here's something I really want to show. I do want to turn on show all objects, jump down to our stage. Let's start changing our support radius.
Very nice.
So because when we change our support radius, our bounding box gets bigger, so that $ymin value is going to get larger. When we subtract that, it's going to still move us up, such that we still sit on the floor object. So let's just scale those back down nicely. And with that,
let's have some more fun. No rush here. Let's make a box. Don't scale it. Use its size for starters. And then
so we can show the fact that, because currently we're only really looking at the translate Y of this object and the ymin of this guy because he's wafer thin.
That's right.
Fantastic. So let's jump up to object level, and I'm going to control click to create a box. And I am going to use the size parameters as opposed to scaling. As mentioned on the whiteboard, we're not taking into account scaling.
In fact,
the expression becomes
we'll end up wrapping this video up with showing how scaling will cause it to explode.
That sounds cool.
All right.
So I'm going to boost the size really large, something like that. Fantastic. And then we can jump inside our stage, and we can say, okay, I don't want the floor to be our floor object anymore. Let's grab our box. Boom.
Beautiful.
And we can jump back up, and we can go back to our box, and let's start changing the size just in Y.
Very nice.
But if we were to change the scale, maybe not quite such large values. Yeah, you can see that the scale isn't being taken into account, and the fact that these scale values do not affect the bounding box information at the geometry level.
Now, if you care to solve this interesting dilemma, it's actually a lot of fun. And Steve and I talked about demonstrating how to go about doing it in this video. But if you're going to go this far and you're going to take into account scale for this guy, you also need to take into account scale for the other guy, because the other guy, being the stage, could also have been scaled. And then if you're going to take all of that into account, you now need to take into account if pivot points have been moved, because all transformations are calculated off of that pivot point. And this gets more and more complex when you could just use a move tool and position the object.
Yeah, it becomes a point where you have to basically weigh up between an expression that, is really cool, but it's practicality, and if it's going to be much less time consuming to do it by hand,
that's right.
Do it by hand.
But I wanted to point that out, and I also want to point out that if you decide to perhaps take, on a personal challenge of, let's just accomplish taking into account the floor object being scaled, not the stage. That's a great challenge to take on and very doable. You need to start thinking about the order in which things are calculated. Yeah. That's very important. SOP level stuff is calculated first before our object level transformations are calculated.
And this guy is essential. The transform order at object level tells us that we're doing scales, then rotations, then translations. So if you are going to piece together much more different parameters when dealing with scaling and translations at object level, you need to think carefully about what's happening with the scaling and then the fact that translation takes place afterwards.
Yeah, otherwise you'll end up with totally wrong sets of numbers, and that's not good. Okay, well, Steve, go ahead and reassign our stage to sit on our real floor.
Yeah, and I'll delete out our box as well. So let's delete out our box and specify the floor.
Okay.
And I'm also going to right-click on our stage asset, come down to Save Operator Type, right click, and come down to match current definition.
Fantastic. And with that, that will wrap up our stage digital asset. Thanks a lot.